All right, here we go. It's Tuesday, February 4th. Thank you, Micah. Thank you, Lauren. February 4th is Tuesday. Welcome to pre-algebra. We're going to go over the answers to 337. Then we're going to jump into percentage of increase or percentage of decrease. Why do we use this term percentage? Because when you put things in terms of percent, it allows you to compare a variety of things in life. Always going back to how many would that be out of 100? Percent is widely used. Get the hang of percent because you're going to be using it. You know how some people say there's things you don't use in math later in life? You will always use percent. Stop it. And get in your proper seat. Yes. Number one. When you did number one on 337, you should have gotten that in lowest terms 3 to 1. Preferably 3 over 1. Written as a fraction. Number two, 1 over 2 in lowest terms. Number three, 5 over 1 in lowest terms. Any questions on 1, 2, or 3? I didn't say comments. I said questions on 1, 2, or 3. Number 4 through 9. 60, 10.5, 2, 21, 48, and 39. Any questions on 4 through 9? So, either everybody got them all right, or once I said the right answer, you looked at it already and said, oh, I get it. Or you're still sitting out there, I don't know how I got that, I don't care. I'll get my C on the test. Hope I don't get grounded. Yes, David.
I don't understand number 9. That's the other one I got.
Okay, number 9, David. I actually did on the board yesterday, but I'll do it again.
Thank you.
Okay? I did it on the board yesterday. You have to set up an equation, David, where 95 times 8 equals 19 times z plus 1. Stop there. Do you understand that?
Yeah.
Every equivalent fraction, or in this case we call them proportions, every equivalent fraction must products be equal. So 19 times, is this what messed you up, David? That old distributive property? 19 times z plus 1, you set up like that. That's got to be the same as 95 times, is it 8?
Yeah.
8. So the first thing you do, 19, you do what, Mitchell? You distribute it through everything in there. Because there's going to be times later, there's going to be more than 2 terms in here. As you progress in algebra, you're going to get 2, 3 or 4 terms in there. A lot of times 3. So I distributed everything in there. 19 times z, 19 times 1. Why am I writing positive? Because it's a positive 1. It was a positive z. What's 95 times 8? 760. How do I get rid of the 19? Now look, we're at this stage. And a combination of frustration, disappointment, anger, all these things rush through me when we are in February. And if you don't know how to do it from here, and you haven't made that a big deal, that's a problem. If after, this is the 100th day of school,
It is?
right?
Yeah.
Okay, but they're celebrating it today. So let's do a fair estimate. Would it be fair to say that I've done 500 problems on the board? I think it's more. I think I do more than 5 problems.
I think I've done 1,000.
Okay, so if after, think about this, middle schoolers, if after I've done maybe 1,000 problems on the board in this math class, you're still sitting there and you don't know how to tackle this, that's got to be tackled like today. we can no longer have middle school math students not knowing how to attack this. I got to get rid of the 19. Subtract 19 just from one side?
No.
No, that'd be silly. That'd be actually lying. If you just subtract 19 from this side and not that side, and still say they're equal, pants on fire. 19z equals 741. How do I get rid of the 19 now? It's attached to the z, not through addition, but through multiplication. How do you undo multiplication? And the answer is
39.
39. David? Number 10. You save 40% when buying a shirt that originally cost 29 bucks. There's two ways you can do this because there's more than one way to skin a cat. So you can do 40% of 29. Watch this. You can do 40% of, did I say of?
Yeah.
Multiplied. You can do 40% of 29 and then subtract what you get there from 29 to take that 40% off, or you can say to yourself, hey, the whole price is 100%. So if they take 40% off, that means I'm paying 60%. You can get this done in one shot by just multiplying by 60%. You can do two steps, multiply and then subtract that from 29, or boom, done. Either way, you're going to get $11.60. Yes?
Is it okay if I did, so I did 10%, figured out 10% of 29?
Okay, yes, sure, Kira. See, there's more. She said she figured out 10% because she knew that would be $2.90. So then she just multiplied that by 4. See how many ways there are to skin a cat?
I don't know.
290 times 4 is 1160. So she did it a different way. But that's actually more work. All right. Yeah, quick. Shh. Run out of time.
Can you just say the answer to 4 again?
Number 4 was 60.
Okay.
Okay, numbers 11 through 13. If you look at the circle graph and you added up all the flowers, it equals 30. So everything you do on that graph is going to be based on a denominator, the total always goes in the denominator, of 30. So how many flowers did you plant? 30. Number 12. What percent is roses? What percent is 9 out of that 30? More than one way. I could set that equal to 100, but you don't want to do that. You want to go like this. Actually, you can easily reduce that to 3/10. Now, if you reduce that to 3/10, I think you all know 3/10 is 30%, right?
Yeah.
So why do this when you can do this? And again, middle school, 3/10 by now should be like automatic in your brain. 0.3 is the same as 0.30, 30 hundredths, 30%. You follow that, Cam? 0.3, 3/10. 0.3 is the same as 0.30. 30 hundredths. What does percent mean? Per hundred. Hundredths. Number 13. What two types of flowers combine to equal 70%? You would combine what two types of flowers to get to 70%? What do you think? Roses and carnations would give you 21 out of 30. That reduces to 7/10. 70%. Follow that? Turn the page. Okay. Percent of increase, percent of decrease. Let's say something cost $100. Let's start with something that has a denominator of 100. because that means percent, right? So let's say you go to the store and you're buying something that costs $100, but they tell you that today there's a decrease in the price of 10%. How much is that going to cost you? Just use your math sense real quick. How much is that going to cost you? $90. Is there anybody that didn't think that? It's $100 and they say it's going to be 10% off today. We're decreasing the price 10%. Does everybody think $90?
Yes.
Okay. How? No.
I moved the decimal twice, but
Okay. How do we arrive mathematically without just saying, oh, 10% off, $90? We take the original price, and if they're taking 10% off, we go like this. 100 minus 10, we put it over the original price. 90 over 100, 90%. Take whatever they decreased it by, what's your denominator always going to be? The original price. So if they decrease it, subtract. If they increase it, add. Let's say you went there and you thought it was going to be $100, and they said, oh, 10% more on Tuesdays. You're like, I'm not shopping your store on Tuesdays. I know, crazy. I'm just making it up as I go. What if they said it's 10% more on Tuesdays? How much would the thing cost now? $110. You know how you would get that? You would say, okay, it was 100. They added $10 to it. $110%. Anything over 100 is percent. You ready to go?
yes.
Let's do number one. On page. Do I just say do it, or do I do more examples with you? Let's go to the middle of page 339, and let's do number one. The original amount is 50. The new amount is 36. Where does the original amount always go? In the denominator. Now, hold on. What's going to be in my numerator? Not 36. The new amount's 36. I want to know what is the percent that they took off. I got to find the difference. I got to find the difference between the original and the new. What's the difference between 50 and 36? 14. 50 minus 36 is 14 over 50, and then you convert that to percent. How would you do it? 14 divided by 50. Or, if you're using math sense, you're like, wait a minute. If I times those both by 2, 28%. I would get the same thing if I did that. You always can do this. 14 divided by 50. You get 0.28 there. 28%. Raise your hand. I'll do that one again if you need me to. It was 50, the original. The new is 36. What's the difference? Say it out loud. It was 50. The new is 36. What's the? Put that over the original price. What do you put it over? What's always in the denominator? The original price. Wait. The original price goes where? Where's the original number go? Are you getting sick of saying it? What goes in the denominator? Always. The original. What goes in the numerator? The difference between what it was and what it is now. Yes?
Can you do that again? I just don't know how you can.
Read it. What's the original amount? And what's the new amount? Okay, so we're trying to figure out, hey, what percentage is that? How much did it go down? If the blouse was $50 and I go in there and now it's $36, hey, how much off am I getting? I'm getting 28% off because it went down 14 out of 50. Go ahead.
But why do you get subtract the, like, why do you?
The original was 50. It went down how much? 14. Because 50 minus 36 is 14. What do you want me to subtract the 36 from?
Actually, but I'm saying, why would it be 36 at the top?
If it's what?
But why would it be 36 so you can, could you put 36 at the top to find the percent that is, and then?
Subtract it from 100? Sure. Did you hear what she said?
No.
She says if you just put 36 over 50, you would figure out that would be 72, and she wants to subtract that from 100. I don't know why you want to do all that. You could, and you still get 28. Number 2.
Yeah.
The original amount is 10. The new amount is 29.5. What's the difference? And where does the original amount always go? Denominator. So I'm going to start immediately by doing this. The original amount, I'm going to make myself a fraction with 10 as the denominator. Do that. First thing I do is take the original amount, put it where? Okay, now it was 10 and now it's 29.5. Next thing I got to do is, hey, how much did that go up? What's the difference between 29.5 and 10? You could do that mentally right now. 29.5 minus 10. 19.5. Where am I going to put that? Right here. That's weird. You got a decimal inside a fraction. What can I do here? I can either do this, or I can say, wait a minute. Times 10 gets me to per 100. What do I do when I do times 10? 195%. Now think about it. Look at it. Ready, David? If the original cost of something was $10 and now all of a sudden was $29.50, that's a pretty good increase. That increased 195%. That should make sense to you. Because if it increased 100%, it wouldn't be 10, it would be 20. Hello? 100% increase is double the price. That's taking the price and adding the price again. That's double the price. 100% increase is double the price. It's 100% increase, not 100% of the price. 100% increase. David?
Would the answer be
195%. Per 100, century, 100.
That would be what we write at the end.
195%. That's your answer. What?
The 19.5, that answer is the 1.2.
Yeah, if I did this. If I did 19, hold up. In case you're confused, if I did 19.5 divided by 10, just like the fraction says, I would do this. And then I would have to move it 2 places to make it a percent. But what I'm showing you is, sometimes you don't have to do this division. If you use math sense and you look at it and you go, wait, 10 times 10 is 100. Just multiply it by 10. This is the way the book's always going to show you to do it, because this will always work. That always works. Division. A fraction is, the fraction sign is, a fraction bar is a division sign. Take the numerator, divide it by the denominator. I'm trying to show you, use math sense. You have a 10 as your denominator. It's easily multiplied by 10 to get to 100. Because you know that percent means per 100. This is the way to do it. This is the shortcut way to do it. Yes?
So if the thing was, like, if it was 100, like, if it was the normal price, it was just 100, so it would be 100%, right? if it was normal price, it would just be
What's 100% of $100?
$100.
Okay,
So if
what
they
we're doing
add a-
today is trying to figure out a percent of increase or
Yeah,
decrease.
but then if you add another 100%, it's 200%, right?
If you add another 100% to the price,
Yeah.
that's like multiplying it by 200%.
Okay. Alright, I was making sure.
Yeah.
about that. Okay.
Number 3, the original amount was 90, the new amount is 110. Evelyn, soon as I hear the original amount, I'm out. Where am I going to put it? Numerator or denominator? No. The original amount always goes where? What goes in the denominator always? Original amount. So, original amount 90. First thing I'm doing with number 3 is starting off with that. Now, how much did it go up? The new amount is 110. What's the difference between 90 and 110? How much did it go up? How much did it increase? 20. Where am I putting that? In the numerator. It changed 20. What?
I heard that.
What?
What?
That's your ringtone.
It's his wife's ringtone.
How do you know
Oh, because I know everything.
She's probably hoping that if it's my girl, it's not some other girl besides my wife. Anyway, what's 20 over 90? Listen, I can always do this. 20 divided by 90. Listen, middle schoolers, I'm trying to help you out here. What's 20 over 90 reduced?
209.
What do you know about fractions with 9 as the denominator? They always repeat. It's 0.2. 2. So if I change that decimal, 0.2, and make it into a percent, what's that going to look like? 22. This reduces to 2 9ths, which turns into 0.2 repeating, which is 22.2%. Now, if you don't, say you can't do that, you always do this. What do you think it's going to be? It's going to be 22. It's going to be 0.2. It's just going to keep repeating. How do I turn that decimal into a percent? Move it 2 places to the right. Whoop! 22.2%. Got it? Percentage of increase or decrease. Here's your word. Ready? Page 340. Let's do number 1 together. Ready? When the original amount is less than the new amount, we call that percentage of change an increase or a decrease. When the original is less than the new amount, that's a percentage of increase. The original amount is less than the new amount. That's going to be an increase. Okay? Your job is to do numbers 2 through 12. 2 through 12. Go. Is this important?
Page 340.
Why do you guys have Jaden's pencil case?
She'd like build a
Oh, be nice.
Isaac, A, you're doing your work now. B, everybody around you is trying to do their work. Number 2, as soon as I see the words original amount and I see the number 10, guess where I'm putting it, Dina? in the denominator. I'm putting 10 right away in the denominator, Evelyn. And now I got to figure out if the new amount's 14, how much did it go up? 4. It went from 10 to 14. It went up 4. My denominator's already 10. 4 over 10. I hope at this point you don't have to do 4 divided by 10. Hopefully you're like, oh, 4 tenths, 0.40. Hello, 40 hundredths, 40%. If not, you got to write 4 divided by 10 and do the division. You got 78. Where are you going to put it? Where are you going to put 78?
In the box.
Okay, 78 is decreased by 22%. You got to find 22% of 78. Number 4, 78 is decreased by 22%. Find 22% of 78 and subtract it. Or from 78. This is one we started with. 78 is decreased by 22%. So I'll do the whole thing. $17.16. So I got to take 78 and decrease it by 17.16.
But what exactly, what you have to add it all?
What?
Oh my goodness. Dyslexia.
Start from the left.
Okay, 60.84. Guess what I would get if I did 78 times 0.78? 60.84. 22%. What number?
Oh, you're on 4. Okay. I
Decrease.
thought you were on.
78, David. 22% of 78 is 17.16. Do you follow that? Since it's a decrease, David, I'm going to take that 17.16 and subtract it from 78. If it was an increase, David, what would I do? I would add it to 78. You sure? Now, David, the thing I said after that's not in the book, the shortcut, the extra outside the box, Mr. Franken taught to you, quote unquote, shortcut, is if it's 22% less than 78, if 78 is going to be decreased by 22%, isn't that the same as 78% of 78? Anybody catch that? There's got to be somebody out there that caught that. If you're going to take 22% off of 78, isn't that the same as 78% of 78?
Yeah.
So listen, if you don't get that, don't do it. That's a shortcut. That's getting it done in one step. This is the way you always do it, following the rules. 22% of 78. It's decreased, so subtract it from 78. This is number 4.
What numbers do you remember?
Find out what. Hey, it says 78 or decreased by 22%. What is 22% of 78? Multiply. Oh. Remember those days? Oh. 22%, 0.22. Good. Decrease, subtract. If they would have said 22% increase, you would just put a plus sign. Yeah.
Okay. So,
That's it. Number 4. Number 5, 105 is decreased by 78%. Casey's going to take 105, multiply it by 0.78. Why? Because 78% is 0.78. Whatever she gets when she multiplies those two, she's going to subtract that from 105. Because it's a decrease. She's going to subtract it. Isaac may have thought, wait, if it's a decrease of 78%, I'm just going to multiply it by 22%. And that'll be my answer to it. Right, Bill? Right, Micah? Not wait. Sorry. What'd you get?
23.1.
Bingo. 23.1. Number 5.
Good job.
Wait.
Good job, Micah.
I know. I know.
Numbers 2 through 12 only. Yes.
Oh, the number.
And you got the 0.